This question involves solving a bearings problem using the cosine rule. The question is taken from the Corporate Maths worksheet, cosine rule apply section, and it's question number 9. To solve the problems, we use the cosine rule, which is here: a squared equals b squared plus c squared equals 2bc cos a. The thing to note here that the capital letters are used for the corners, for the angles, and the lowercase letters are used for the sides, and each lowercase is opposite its uppercase letter. This question also involves bearings. Things to note or to remember are that bearings are measured clockwise from north. Obviously a complete turn will be 360 degrees, so you can find a missing angle if you know one bearing. And also all norths are parallel, so we use the parallel line rules of the co-interior angles add up to 180 degrees, so if we have these two angles here, they will make 180. So here's our question. Two ships A and B leave a port at 10:30. A travels on a bearing of 196 and B on a bearing of 244. So probably a good starting point with this is to draw the question. So I'm going to put my port here, put on a north. Now the first ship travels on a bearing of 196, that's greater than 180, so the bearing is going to come down this way. This is ship A, and that angle there is 196 degrees. I'm going to change colour and show the bearing of B, which is 244, which is a larger bearing, so it's further round. So 244 maybe come round to about here, and that's ship B, and that bearing is 244. And the ships travel at different speeds, so ship A will be travelling at 30 kilometers per hour, and ship B is at 24 kilometers per hour, so clearly ship A is going to travel just a little bit further, so I'm going to just cut this line a little bit and make it clear that it's a shorter distance. And the question asked initially for us to find the distance between A and B at 2 o'clock, so that's this distance here. I'm going to call that distance x. Now, just looking at my diagram, I can immediately write in another angle, which is this angle here, because if it's 244 for the red angle and 196 for the blue angle, then the difference there is going to be 48 degrees. I'm going to write it here, 48 degrees. And it's going to be helpful if I work out the distances, because I don't have any distances, and I can work that out using the speed and the time. So if we start at 10:30 and we go on till 1400 hours, that's a time of 3.5 hours. So that's going to be useful. Speed, as you should know, is distance divided by time, so therefore rearranging that, I get distance is equal to speed times time. So the distance for A is the speed of that ship, which is 30, multiplied by the time, which is 3.5. It gives me a distance of 105 kilometers, so that ship has traveled 105 kilometers. And then the distance for B is 24 kilometers an hour. That's the speed for ship B, multiplied by the same time, 3.5, which is 84 kilometers. So that's 84 kilometers here. And what have we got? Well, we actually now have a triangle where we have two sides that I know, one side I want to know, and I have the angle. So that means I can use my cosine rule. Cosine rule is here. So let's put my values in. Let's do this in blue. I will have a squared. Now a squared is the side opposite the angle that I'm working with. I'm working with angle 48. So that makes my formula x squared equals the two other sides, so 84 squared plus 105 squared, take away 2 times BC cos A. So 2 times 84 times 105 times the cosine of my angle, which is 48. So if I simplify the right hand side using a calculator, my x squared is going to be 6277.54. X will be the square root of that, so the distance x is 79.23 kilometers, and that's the distance between A and B. So part B of this question is far more complicated. We're looking for the bearing of B from A. So that would be with a north here. I want this angle going all the way around. Now to do it, I'm going to need to work out the angle first of all inside my triangle. So let's just focus on that triangle. So I'm going to redraw just the triangle I'm going to use. This is A, this is B, and this is P for port. I know that this distance is 84 kilometers, this distance is 105 kilometers. I know that this angle here is 48, and I worked out in the first part that this distance from A to B is 79.23. But I want this angle here, so actually I can wipe out this 48, I don't need that one. Let's take that away, just focus on what I need. I want to work out the angle at A. So I can use the cosine rule. So I'm going to say that 84 squared, because 84 is opposite the angle that I'm trying to find, equals 79.23 squared plus 105 squared minus 2 times 79.23 squared multiplied by 105, sorry, not squared, just multiply by 79.23 times 105 times the cosine of A. I'm going to leave you to solve that equation and to come up with the value of A, and you should end up with the value of A being equal to 51.99 degrees or 52 degrees. Depends how you round the question. So I know this angle here, write it in blue, is 51.99 degrees. Now I want the bearing of B from A. So let's look at the bearing side of things for my question. Pull this up here. Again, I've got B, I've got A, I've got P. I'm going to put norths on A and north on P. Now I want this angle going all the way around there. So I'm going to look at these angles here, this angle here and this angle here, because my norths are, I should have labelled N for north, my norths are parallel, so the two angles inside will add up to 180 degrees. Now I know the red angle there on the north of the port, because if I zoom down, I had 196 degrees this way, so take that from 360, I get my angle here, and that's going to be 164. So I know that this angle here is 164 degrees. That then works with this angle here, they add up to make 180. So my little angle here is going to be 16 degrees. I previously worked out that the angle going this way is 51.99. So my missing angle here that I want will be 51.99 subtract 16, which is 35.99 degrees. And then, oops, got a little mistake there, that should have come from the north, my bearing. So my bearing of B from A is the angle down here, and that's simply 360, take away my little green angle, which is 35.99. So the bearing of B from A is 360 minus 35.99, which is 324.01 or 324 degrees.